Hello everyone, today we are going to cover variables, constants, plotting points, and inequalities. Few vocabs, variables, a symbol that represents a quantity that can vary, typically a letter. Example 1, use a variable to represent a quantity. So for letter B, let n be the number of people who work from home at least once a week doing normal business hours for year 2013. N equals 20. What does that mean in this situation? In 2013, 20 million people worked from home at least once a week doing the normal business hours because N is representing in millions. So don't forget that part right here. Make sure your units is attached. Letter C, let T be the number of years since 2010. What does it mean when T equals 5? When you have that as your base, you add 5 more to it at 2015. So T equals 5 represent the year 2015. And we're going to use that idea a lot too. Example number 2 says, using a variable to represent a quantity. When you talk about quantity, that means at n could be anything, could be any number. So in this case, when they talk about number 1, the weight in pounds of a baby at birth, that means just using any letter you pick. For example, let's just use x for this case. X. Example 1, using a variable to represent a quantity. Let S be a car's speed in miles per hour. What is the meaning of S equals 60? Well, the meaning of S equals 60, saying that the speed of the car is 60 miles per hour, or the car speed is 60 miles per hour, or any of those things, as long as you said the speed of the car and the 60 miles per hour somehow in your sentence, then you should be okay. So I'm gonna pause the video and write it down. Example 2, using a variable to represent a quantity. Use a symbol to represent a given quantity. Explain why the symbol is a variable. Give 2 numbers that the variable can represent and 2 numbers that cannot be represented. So the first question says the weight in pounds of a baby at birth. You're gonna pick a letter. I don't care which letter you want. You can use X, you can use W. So I'm gonna use W. So I'm gonna say W is equal to the weight at birth. There's a couple ways you can represent. W equals the baby weight at birth, birth weight, baby of a baby. All those is representable. So you can represent them. Now, they want you to give you 2 examples, that 2 numbers that two numbers that cannot be represented. So in this case, you can have a number that is workable for baby weight. You can have a 6-pound baby. You can have a maybe a 8-pound baby. Okay. You can have something that's not possible. You cannot have a 20-pound babies, or you cannot have a 30-pound babies. So I would like you guys to understand that there are certain numbers that work for situation, and there are certain numbers that cannot be working at the situation. Example number 2, the number of people who live in a 2-bedroom house. So please use example number 1 as your guide, and please pick a letter for example number 2 and give me 2 numbers that works and 2 numbers that does not work. So for example number 2, the number of people who live in a 2-bedroom house. My letter is going to be N. You could use X. You don't have to follow mine. The number of people who live in a 2-bedroom apartment house. 2-bedroom house. Example, giving you some possible numbers that you can work with. The number that works is 2 people, 4 people. Example, for the numbers do not work, you can have 10 people or 20 people or even more. Depends on, something that cannot happen to have all those people living in. Please make sure you know what number works here and what number does not work. The next thing we are talking about is called the constant, a symbol that represents a specific number, a quantity that does not vary. That means it does not change. Example 3, compare constant and variables. And then so in this case, example says a rectangle has an area of 12 square inches. Let W be the width in inches, L be the length in inches, and A be the area in square inches. So now I want you, number 1, sketch the 3 possible rectangle of an area 12 square inches. So in this case, I want you guys to draw the rectangle and just label them. So I'm gonna do 1 on one side and 12. So the area is going to be 1 times 12. So that will work, 12 square inches. So that is the first one that you can use. Now I need 2 more. So I give you example number 2. There's my choices. There's another one, 3 times 4 is 12. There's, I don't know, is there any other possibility? You can definitely draw it the other way around. You put the 3 on up here and then 4. That's totally okay with me. So example number 2, number 2, which of the symbol W, L, and A are variables? Well, they are W and L is variable because those are the numbers you pick. And then once you pick W and L, then your A is always going to be set as a constant. So in this case, we are going to write that down and just jot down the information for 2 and 3. So in the case right here, example 3, going back example 2, W and L are variables. Explain, well, because those are the numbers that can change. 3, which of the symbols W, L, and A are constant? Well, in this case, A is a constant because A is constant based on the picking the L and W. Going down to a few more things. Counting number is natural number. Just think about the natural when you were a little baby. When your mom and dad start counting your fingers and toes, they always start with 1. So that's your starting counting your numbers. 1, 2, 3, 4, 5, and goes on. And the integer number is whatever the number, those dot 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 means that goes on and on. That's the etc. etc. So in this case, it could be -4, -5, and then but what we're going to do is we are going to just use the 3 dots to represent that. That's going to be anything -3, -2, -1, 0, 1, 2, 3. So in this case, it's negative, okay, and positive and 0, okay? It's negative whole number and positive whole number. And then negative integer and positive integer gives you the integer plus 0. So now what you're going to have is positive integer is 1, 2, 3. Negative integer is -1, -2, -3, -4, and go on. Because those 3 dots tells you that things goes on forever. 0 is neither positive or negative. It doesn't have its own positive or negative sign. Under integer, you have to remember it's the positive integer and the negative integer and the 0. That's the 3 parts that makes it. All right. So now example number 4 tells you graphing integer on a number line. I want you guys to understand it's drawing dots. When you graph integer, is dots, not a line. Draw dots on the number line to represent integer between -2 and 3 inclusive. Inclusive means include those 2 numbers. So in this case, if you draw a number line right here, you have 0, you have -2, inclusive. That means -2 is going to get that. -1 is going to get that. 0 is going to get that. 1, 2, 3. 1, 2, 3. They are all going to get dots. It's integer. Please make sure you know that. Please make sure you know that. And inclusive means including, okay? Wants you to draw dots, again, integer, on a number line, represent the integer between. So in this case, that's only between, right here, -2 and 3. That means it's not inclusive, so we are not going to graph those dots. So you have 0 right here, you have -2 right here, -1, 1, 2, 3, and we are going to dot them with the -2 and +3. Okay, so make sure you know that because we're gonna quiz you on that part really closely. Don't forget the difference between inclusive and if I didn't say the inclusive, you do not including those points. And also, it's integer, it's dots. We're gonna talk about is the rational numbers. And when you do rational numbers, the definition is a rational number is represented by a fraction, very important fraction, or the number of that can be written in a fraction form. So in this case, n over d. When n and d are integers, so therefore there's no decimal top and bottom, and d is non-zero. That means d right here cannot have 0. So in that case, what you're going to have is you are going to, n in this case is stand for numerator, and d in this case is stand for denominator. So I'm gonna pause it and write those words down. Here is n is for numerator and d is stand for denominator, and the bar in the middle right here is a fraction bar. I don't want you guys to start using those vocabulary so you understand what I'm talking about, or how we can communicate in math if you prefer. We can use bigger words, making ourselves feel so much smarter. So here we go. Next one, what we're going to talk about is a fraction can be used to describe a part of a whole. What does that mean? Well, in this case, I like to think food, all right? So in this case, there's a pizza. I know a lot of you guys say, Miss Wiesman, why we in junior high, our teacher teaches us in pizza. Yes, but pizza can be cut into any pieces. Now, why is that important? Well, it's because you want to have the same size to compare. So in this case, pizza can be cut in every single size, and then you just want to have part of it, the ones that you want. So really, the fraction is based on the part you want, you have, how about that, over the whole pizza, or how many pieces you cut it, how many total. I know a lot of you guys hate fraction, so we're going to try to understand this better. The next thing we're going to talk about is irrational numbers. Irrational numbers, think about people who are irrational, somebody who you cannot predict. And then so in this case, when you think about rational numbers, is things you can predict. For example, the numbers that keep repeating over and over, 6.33333, or you can have things that's like you can have 4 over 3, all right? All those are okay as example. But if you have an irrational number, it's something that you cannot repeat and you don't know what they are like. The digits keep on going in decimal. So irrational number is a number cannot be written in the form of a fraction, where n and d are integer and d is non-zero. For example, now we are talking about things like pi, and you know from geometry when you're talking about pi, it's 3.1416 and blah 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 blah, and your teacher told you that there's no way you can ever figure it out, so we just kind of round it. So when you do a rounding, that's also called approximation. So we're gonna talk about that in a minute. So square root 2, that is going to be an irrational number. Anything that is not a perfect square root is also irrational number because they do not have a pattern. You cannot put a little bar over it. The number just keep on going and going and going and going. And then people throughout centuries and centuries try to prove it, and they have not been able to find a number that can put in a pattern. So in this case, irrational numbers are numbers that does not have a pattern. So in this case, I'm give you some example right there. So now next one, and then you can also think about the numbers that is not rational. Numbers non-rational is also called irrational. So decimal in this case is going to be any rational numbers written in terminate or repeats. Decimal is terminates or repeats. What does that mean? Terminates means like half, and that's going to be like a 0.5. Repeats is things like 1/3, and that's equal to 0.333 and so forth. So we can actually say that's 0.3 repeat. That's decimal. Irrational number can be written as a decimal number using approximation. Okay. Sorry. Irrational numbers can be written as a decimal number using approximation by rounding. Okay. So irrational is the number like this. We talk about pi. Pi is going to be like 3.1416. And when we round, that's an irrational number. We will write it like with a little squiggly line, okay, equal sign, but it's little squiggly line. That's called approximation. We can say that's 3.14. Depends on the situation. Your teacher might want you, or I might want you to round it a little bit longer or a little bit shorter. The longer you round, you have a better chance to get a more precise, closer approximation, a better approximation. So in this case, a decimal, for example, square root of 2, we can just kind of round the number, and that is going to be, so in this case, square root 2 is going to be around 1.4142135, and it goes on forever. So I'm going to just round it to 2 decimal places, and please read your homework or your question properly to see how many decimal places you have to round it to. If I say round it to hundreds place, you gotta use the thousands place to round it to. So in this case, you're just looking at the 4, and since 4 is smaller than 5, we drop that number, okay? You are keeping this when you look at the hundreds place and you look at the thousands place. If I want you to look at hundreds place, you use the thousands place to round, and that is the decimal, okay? Moving on to real numbers. Real numbers is all of the numbers represented on the number line. So real number also have another definition, says all the numbers on the number lines. Example number 5, graphing real numbers on a number line. So in this case, what you're going to do is you are going to just draw a number line. You can use your calculator to do it, or you can just say, hey, if it's negative, I know it's on the left hand side of the fraction, and I'm gonna say this is gonna be bigger than 1 but smaller than 2. So here's my -2, here's my -1. And if you want to, this is really 7 p's out of 4 p's. Okay, so it's gonna be 7 p's but 4 right here. So 3 more left, because if you take 7 minus 4, one of them is whole right here. That's your whole right here. That's your whole, okay? You can change that into 1, -1, and 3/4. So that's just 1, 2, 3, and right here will be your -7/4, okay? The reason for that is you are taking 4 pieces to make a whole. So that's gonna be your -1. Then what is left then? Well, you only have 3 pieces left. So that's where the 1 piece, 2 piece, 3 pieces come from. So that's example number 1. Please try example number 2 yourself, and that's just a very basic decimal. I would like to know where you're going to put your 0. Is it to the left or right of the 0? Label 1, 2, 3. I would prefer to have at least definitely a 1, so I know how big of the spacing is. And I would like to have the number before and after for your points purpose. Okay, and then because this is 0.3, please do not please do not dot the points closer to 3. It should be closer to 2, and it should be like less than half. So when you graph things, now you are seniors, I expect you to do a better job of graphing those kind of points if it's necessary. So now I want you to have a real number diagram, and I'm gonna pause it and then I will explain it when I'm done. So the real number diagram goes like this. You start off with the counting number, natural number right here, and that is something like, then you have the integer, and don't forget that's a positive counting number, negative counting number. So that's going to be -3, -2, -1. Don't forget your 0, okay? And you have the 1, 3, and then you have the rational number, and the rational number is the one that has a fraction, like 1/3. You can have 4/2. You can have all those kind of stuff. And then don't forget, and then you can have rational, have a pattern that has 0.3 repeating decimal, and then irrational is like you have a square root of 2, you have pi, and that's where you approximate. So there's another one in the middle of it, but I will talk to you guys. But since the book doesn't cover it, I will not, bother you guys with it. All right, so that is real number diagram. Okay, the next thing is the definition is called the data. And data is quantities or categories that describe people, animal, or things. So what does that mean? Let's look at example. Example 6 says graphing data on the number line. Graphing data. The total amount in billion of dollars of new federal student loan for the year 2008, 2009, 2010, 11, 12 are $69 billion, 87 billion, 107, and $108 billion respectively. So in this case, 69 is matched up to 2008, 87 is matched up to 2009. That's what respectively mean. The source is from the College Board. Let L be the total amount in billions of dollars of new federal student loan in a given year. Now they want you to graph the data. They pretty much just want you to put down the data is going to be the numbers in billion dollars, because that's what they want you to do. So see the L be the total amount of $1 billion, and then give a year. So they want you to graph the data, and that's the data. So in this case, I am going to just start probably like a 65, and then I'm gonna go 70, 75, 80, and 85, and 90, and then and so forth. So I'm gonna pause my video, and then you guys graph the dots, okay? So if you look at the graph the data, I give a title. You usually should always give a title. That's what I will be looking for if I have you guys graph. Then I label the point clearly, and I give a units. on them. Okay, so that's what the graphing the data mean. Graph the data. 2, did the total amount of loan increase or decrease and stay approximately consistent, or none of this from 2000 inclusive? So in this case, it says what happened. We know the total amount of loan is increasing, but we cannot tell because it's not consistent, and then we don't know what's going on. So we can only know the total amount of the loan is increasing. So I'm gonna write that down. And I will pause the video and write that down for you. Okay, so this is the only thing that you have to write a lot, but once you understand what I'm saying, hopefully you understand what I write down. The only reason I'm writing it is a process. Okay, so because I need to teach you guys how to think it. So for number 3, it says, did the increase in the total amount of the loan increase, decreasing, stay approximately consistent? That means the same. Or none of this from 2008, 2012 inclusive. That means including those numbers. Explain. So in this case, if we look at it, from 69 to 87, that's a big, huge gap. From 87 to 100, that's a big, huge gap. But then 107 and 108, notice the gap got smaller. So here's what I wrote. If we look from left to right, the points plotted on the graph, which is what I did, we see that the distance between adjacent points, means next to it, decreases. Big, very big, getting a little bit smaller, small, and then very tiny, okay? And the adjacent point decreases. So that's the gap in between each point decreases as it goes, years goes up. That means the increasing in total amount of the loan decrease. That means the amount of money that federal government is giving, it has been increasing less and less. From here it's only 7 billion, and from here to here it's only 1 billion. So the amount as we increases, but you only get a little bit add on to it. That's what they are saying. Okay, so I need you guys to think about it. If you have any question, please ask me. Going on the positive and negative numbers. Positive numbers and negative numbers, you look at a number line. So I'm going to draw it in the number line. All right. And then so in this case, that's 0 in here. And this is the negative side. So that is negative numbers. And then from here to here and on, that's positive, and that's all I need you to know. And you have to understand that's a positive infinity, that's a negative infinity, and you should know that. And then you should know infinity means goes on forever. That's positive numbers, and negative infinity means goes to the left. It means forever goes on. Then what we're going to do is we are going to talk about coordinate system. There's a lot of things we're going to talk about in coordinate system. And eventually you will need to know how to plot points and all those kind of stuff. So in the coordinate system, you get a graph. It's a 2D figure. You get an X, you get a Y. And then so now what you're going to have is you need to know all the different things. And when you talk about order pair, this is just you have an X and Y. You have a number for the X, you have a number for the Y. And you have a coordinates, and that is the number that you put down. And that is going to be, you have the X coordinates, and then you have the Y coordinates. And then you have the x-axis, that's the x-axis, and you have the y-axis. And the origin is at 0, 0. And quadrant is 1, 2, 1, 2, 3, 4. Okay. And then it's a C for cookie. If you want to remember, C for cookie. And that's how you can remember. That's 1, 2, 3. And then this is 0, 0. That is going to be the order. And don't forget, when you apply your order pair, is you go X first, then Y. So now what we're going to do is we are going to plot the points on your coordinate system. Plot the points for you. And I also labeled it. And labeling points is very important in this class, just because eventually when you guys have to take the final, we do expect you to label those points. So let's start practicing them. Okay, so make sure you plot them and you label them. Make sure you understand this is your X first, and that's your Y. So you go left and right first, and then you go up and down, okay? And then the next thing, inequality symbols, you have the greater than, you have the less than, you have greater than equal to, less than equal to. Those are your symbols. Now, I found out that a lot of you guys get very confusing about which way is which and how to read it properly. So I would definitely quiz you guys on that, okay? And I will make you guys read it to me so you are 100% sure, because it's not hard at all. Please ask for help if you need some, okay? All right, first of all, interval notation. Interval notation is going to be something that we have to talk about. And interval notation is based on little brackets and parentheses. And we definitely do some of it last year. So first of all, in words, and I need you to translate and graph it. And then we're going to talk about interval notation. And here is X numbers less than 3. I'm going to use the numbers. It could be anything. So therefore, it's going to be a letter. So X is less than 3. Okay, any number smaller than 3, that's what X less than 3 means. So that's going to be this graph, 0, 3, and then number is going to be open circle because it's not inclusive. And then some of you guys probably see I did this before. For some of you guys in my class, you also get this kind of graph. And in the higher level math classes, you might see them to be done this way. So 3, and then you will actually get a bracket. Oh, I'm sorry, bracket or parenthesis. So here's in parenthesis going this way. Parenthesis is representing open circle, and bracket means closed circle. Okay? So now what you're going to have is interval notation. Interval notation is going to be the same thing. For closed circle, you are going to use brackets. For open circle, you are going to use parentheses. And for numbers that's unknown, so for this case, anything we will use parentheses for infinity or negative infinity. So in this case, if you look at the numbers right here, you have this. Always write down your interval notation from left to right. So since this is going towards the negative side, so that's negative infinity. So I'm going to put down negative infinity. It's going to be negative infinity from left to right. That's parenthesis because I told you guys that up front right here, that's negative infinity or positive infinity, you use a parenthesis. And right here, since it's an open circle and since it's a parenthesis, we are going to use also 3 and a parenthesis. Then the next one, number less than or equal to. So if you have less than or equal to, the letters is going to look like this. You can use N, you can use X. If you use N, go ahead, use N. If you like to use X, go ahead, use X. So X is less than or equal to 3. Now, when you have an equal to, that means inclusive. And if you graph it, here is what it look like. I will put it both ways for you to see. So this is 3. Now, bracket. Remember, closed circle is bracket or is greater than or equal to, less than equal to, you get a bracket. But since it's facing towards the negative side, you also have it this way, or you can have it in a way like this. But you should recognize either way because it depends on whatever your teacher going to use next year. So in this case, let's write your notation. That's going to be, still starts with negative infinity to positive 3. And that is going to be, sorry about that, I forgot to use, that's a closed circle right there. It's a 3. Okay, closed circle, you use a bracket. So there's the bracket. All right, you guys finish the next 2. And we are going to talk about them and double check. So here are the answers for the next 2. X is greater than 3, right here, X is greater than 3. Again, that's an open circle, so therefore it's an open circle, and then it's a parenthesis greater than 3. Think about it, any number bigger than 3. Well, that will be 4, 5, 6, 7, 8. So therefore it's going towards positive infinity because the number like 100, 1,000, a million. So therefore, that's a positive infinity. Since we don't know how the number is going to end, it's going to be a parenthesis. And the next one is number greater than or equal to 3. X is greater than or equal to 3. And therefore, greater than means it's going to be bigger than 3. And if it's a bigger than 3, it's going to be a bracket. It's going to be a closed circle. So in this case, because of bracket, you have to match it with bracket. Bracket is 3, positive infinity. So therefore, it goes on. And going on to the next thing, you have describe value of variables and graph a compound inequality. So compound inequality means you have more than one symbol in one thing altogether. So let's try a couple. 1, let h be the height in inches of a woman whose height is at least 64 inches. Describe her height using inequality notation, interval notation, and a graph. So what we're going to do is we are going to talk about what is our inequality first. So the graph should be h is greater than or equal to 64 because they say at least. Now since they are at least, you have to be minimum of 64 and up. Or if this kind of confuse you, think about it this way. If your brother owes you at least $64, that means $64 or more. Money somehow always works. So describe her height using inequality notation. There's our inequality notation. Interval notation. So interval notation is going to be 64 and to positive infinity. All right. And then a graph. And 64 and bracket and going up. Now, this might be a little bit tricky because guess what? Sometimes we can definitely figure out what's the tallest person in the world, and it's not going on forever. So this is kind of iffy for me. Okay. Now the book actually just uses greater than 64, but this bothers me. So if you guys say, okay, Miss Wiesman, it kind of supposed to stop at certain points, and I totally understand. So I will not ask you a question like that, okay? I will give you a boundary if this kind of question shows up. So now the next one says, a girl went for a run, travel at most, you ate at most 4 cupcakes. Let D be the distance that she run in miles she run. Describe the distance she run using inequality notation, interval notation, and a graph. So in this case, a girl went for a run. Well, if she didn't run, it's really just 0. We don't have a negative number. Travel at most 4 miles. That means that's the highest point you can get. Let D be the distance. So what we're going to have here is really a compound inequality because there is an and, okay? So you have a 0 is when she starting running, and the number is going to be between that and 4. It can only go up to 4, but it cannot pass 4. So that's your inequality. And when you write notation, interval notation, that's going to be between 0 and 4. Why do I use the bracket? Because we know the exact number, it starts at 0. And the graph right here is going to be between 0 and 4. Inclusive. Because you will include when she didn't run, 0. At most, that means you get to 4, but it cannot get more than that. Those are your 3 things. So go ahead, try to see, can you graph the next one? Well, I actually gave it to you. Let W be the weight, 9 pound of a man. Interpret and graph the inequality. So in this case, sorry, there's a typo. It should be I. That should be IN. In pounds. Interpret and graph the inequality. So I gave you the inequality already. Okay, and to interpret is the man weighs between 173 and 177. And I'm going to pause the video and write down the words for you. All right, for example number 3, for the third little question, we have let W be the weight in pounds, that should be I, of a man. Interpret and graph the inequality of 173 less than W less than 177. That means the man's weight is between 173 and 177 pounds. Notice there's no inclusive. And here's my graph. Open circle on both sides, or you can use parentheses on both sides. And then right here is interval notation just in case I ask you. And that concludes the notes for 1.1. Thank you so much for watching.